What if buildings could rise from the ground faster, cheaper, and with near-perfect precision? Right now, across the globe, an army of mechanical workers is revolutionizing one of humanity's oldest industries. These are the robots that are building our future, faster, safer, and with precision that human hands simply cannot match. Meet Apollo, the construction worker who never gets tired, never complains, and never makes a mistake. This human-sized robot from American company Apptronik stands 5 feet 8 inches tall and weighs just 160 pounds. Yet it's changing how we think about construction labor. You've got to see this thing move around a job site. Unlike older robots that need carefully controlled environments, Apollo just walks right into normal construction areas and gets to work, inspecting components, sorting materials, placing fixtures. Its brain uses machine learning to figure out what to do even when things aren't exactly where they should be. It can haul up to 55 pounds of materials and keeps going for 4 hours before needing a battery swap. In February 2025, Apptronik secured an astonishing $350 million in Series A funding led by B Capital and Capital Factory, with participation from tech giant Alphabet. That's serious cash for a robot company. They've also partnered with manufacturing giant Jabil to start mass-producing these units. Soon you might see Apollo robots at construction sites everywhere, working alongside regular crews and handling the dangerous, repetitive jobs nobody wants to do. Now let's jump to Japan, where they've got their own answer to construction labor shortages. The HRP-5P from Japan's National Institute of Advanced Industrial Science and Technology stands about 6 feet tall and weighs around 220 pounds. This robot isn't designed for delicate work, it's built for the heavy lifting that usually breaks human backs. The HRP-5P can autonomously install drywall sheets, a physically demanding task that illustrates the robot's impressive capabilities. It just picks them up, carries them over, and mounts them to the wall, all by itself. Its sophisticated system of joints and actuators allows it to mimic human movements with remarkable accuracy, enabling it to navigate typical construction environments and manipulate standard building materials and tools. This adaptability means construction companies don't need to redesign their work sites or processes to accommodate the robot. Instead, HRP-5P integrates into existing workflows. With Japan's construction workforce getting older and smaller every year, robots like the HRP-5P aren't just cool tech, they're absolutely necessary. Plus, nobody's gonna miss throwing out their back lifting drywall or getting repetitive strain injuries. While humanoid robots offer versatility, some construction environments demand specialized machines. Enter the Walker S, an advanced humanoid robot developed by the Chinese company UB Tech Robotics. Standing 1.7 meters tall, the Walker S features a robust structure with force-compliant drive joints and a rigid, flexible coupling hybrid system that enables stable walking even on mobile production lines. Companies like NIO and Volkswagen are already using these robots in their electric vehicle factories. The Walker S checks door locks, inspects seat belts and headlights, and even attaches logos to cars. Equipped with 41 servo joints that provide force feedback, the Walker S possesses comprehensive perception capabilities through its array of visual, audio, and distance sensors. The coolest thing about Walker S? They work in teams. Just like ants in a colony, these robots communicate with each other to coordinate complex tasks, moving parts, sorting components, placing materials on vehicle pallets. This multiplication of robotic labor significantly increases production efficiency, potentially transforming manufacturing processes across industries. UB Tech Robotics envisions a future where humans and robots work side by side, each contributing their unique strengths to create more efficient and productive workplaces. Not all construction robots look like humans, though. Take the FieldPrinter from Dusty Robotics. This little machine solves one of the biggest headaches in construction, getting the floor plans marked accurately. Traditionally, construction workers spend days measuring and marking where walls and fixtures should go, and even tiny mistakes can cause massive problems later. The The FieldPrinter takes digital blueprints and prints them directly onto concrete slabs with incredible precision. This thing is 5 times faster than humans with measuring tapes and chalk lines, and it never makes mistakes. 100% accuracy. That means no more tearing down walls because they were built in the wrong place. The robot's navigation is so good it doesn't even need a clear line of sight. This means it can print layouts even behind obstructions and obstacles, a common challenge on busy construction sites. The robot's efficiency and precision significantly reduce labor costs and construction timelines, making it an increasingly essential tool for forward-thinking construction companies. While some robots specialize in specific tasks, others aim to revolutionize entire industries. Figure 01, developed by Figure AI, represents one of the most advanced humanoid robots in the world. Designed for general-purpose material handling in logistics, manufacturing, and retail settings, the Figure 01 stands 5 feet 7 inches and weighs 132 pounds, and can lift up to 44 pounds and moves at walking speed for 5 hours straight on a single battery charge. The robot's brain lets it adapt to messy, changing environments, crucial for construction sites where things are never perfectly organized. Figure AI isn't just playing around. They plan to bring 100,000 of these robots to market by 2029. They've already partnered with BMW to get their robots working in the Spartanburg plant in South Carolina within the next year or two. The money world is betting big on Figure AI. They just raised $675 million from tech heavyweights like Jeff Bezos, Nvidia, Microsoft, and OpenAI, valuing the company at $2.6 billion. That kind of cash doesn't flow unless investors see massive potential. Let's switch gears and talk about housing. Azure Printed Homes is tackling one of construction's biggest challenges: affordable, sustainable housing. Founded in 2019 and based in California, this pioneering company utilizes large-scale robotic 3D printers to create residential structures from recycled plastic polymers, addressing both the housing crisis and plastic waste problems simultaneously. Yeah, you heard that right. They're turning plastic waste into affordable homes. Their approach builds houses 70% faster and 30% cheaper than traditional methods. A small 120 square foot studio unit can be produced using the equivalent of 100,000 recycled plastic bottles, with approximately 60% of the printing material comprising recycled plastic, including post-industrial peat from bottles and packaging. The cost advantage is significant. While a traditional studio home might cost around $50,000, Azure's 3D printed equivalent comes in at approximately $40,000. The best part? They can build the whole thing in just 3 days. Azure offers various models from backyard studios to tiny homes, and they're expanding fast with a 15,000 square foot factory in Culver City and plans for another facility in Colorado by 2025. Talk about solving 2 problems at once: affordable housing and plastic waste. While 3D printing entire homes represents one revolutionary approach, Amsterdam-based startup Monumental is transforming traditional bricklaying with its autonomous, AI-powered robots. Founded in 2021, they've already made huge strides in automation, and with 57% of European countries facing severe shortages of bricklayers, these robots couldn't come at a better time. Their bricklaying system works like a team. 2 smaller robots bring bricks and mortar to the main robot, which places each brick perfectly. The whole setup is compact enough to fit through normal doorways and navigate the chaos of real construction sites. These machines work 50 to 60% faster than human bricklayers, and they don't get tired, ask for raises, take smoke breaks, or make mistakes. India's getting in on the action too. Craftsmac Labs created a robot called Masonry that's changing how blocks get laid in multi-story buildings. This versatile robot is designed to tackle the block laying process in multi-story buildings, effectively addressing manual labor shortages and ensuring consistent quality in masonry work. Masonry runs on an electric battery and features an all-wheel drive, making it well-suited for construction sites. It's capable of laying blocks up to about 61 centimeters in length and can be quickly adjusted to handle various sizes and shapes, including autoclaved aerated concrete blocks. But masonry doesn't stop at block laying. This adaptable robot can also handle tasks like bricklaying, cladding, plastering, painting, tile installation, and interior work. Its multifunctionality significantly boosts productivity and shortens construction timelines. Operating as part of a multi-robot system, masonry enhances precision and efficiency across different construction tasks. Craftsmac Labs has put masonry through various tests, including both dry and wet bricklaying, demonstrating its potential to revolutionize multiple facets of the construction industry. For concrete floors, nothing beats the TS6200E electric superflat screed from Luxembourg-based Top and Screed. If you've ever seen a warehouse floor that's perfectly flat, you know how critical this is for facilities with forklifts and robots. This self-propelled machine uses laser guidance to level concrete with incredible precision. Its head spreads concrete, removes excess, and vibrates it all in one pass, covering up to 22 square meters at a time. With 4 motorized wheels that can turn on the spot and a telescopic boom, it maneuvers easily even in tight spaces. Powered by 4 batteries, the TS6200E can process up to 4,500 square meters of concrete on a single charge and run for up to 11 hours. Since it's fully electric, there are no fumes, making it perfect for indoor use. Construction companies can choose 10-foot or 12-foot heads, depending on the project size. Now, most robots in construction are built for one job and one job only, but not Spot. Boston Dynamics' 4-legged robot is shaking things up with its ability to handle a range of tasks, from site inspections to safety monitoring and data collection. Unlike wheeled or tracked robots that struggle with uneven terrain, Spot's agile, dog-like design lets it navigate obstacles and rough construction sites with ease. Outfitted with a variety of sensors, Spot can map its surroundings, dodge obstacles, and operate either on its own or with remote control. It's especially useful for keeping an eye on job site conditions, inspecting hazardous areas, and gathering data that helps project managers make better decisions. And since it can go where human workers might be at risk, Spot isn't just a helpful tool. It's also a safety game changer, helping prevent costly delays and accidents before they happen. The Hadrian X from Australian company Fast Brick Robotics might be the world's fastest bricklayer. This beast can place over 1,000 bricks per hour, something no human could ever match. It measures and cuts bricks, applies adhesive, and places each one with millimeter precision. The robot works in almost any weather, maintaining consistent quality regardless of conditions. It takes a digital design and executes it perfectly, eliminating several steps in traditional bricklaying. By handling the entire process from cutting to placement, Hadrian X removes countless opportunities for human error while dramatically speeding up construction. The Austrians have their own approach with Baubot from startup Printstones. This tracked robot looks like a mini tank with an arm, and it can climb stairs, roll through doorways, and navigate all the chaos of a construction site. Baubot's arm reaches up to 1 meter with 1 millimeter accuracy, handling tasks from bricklaying to welding, drilling, and painting. It runs for 8 hours on electric power, moves at 3.2 kilometers per hour, and can carry up to 500 kilograms. The best part? It fits in the back of a truck and sets up quickly, so you can easily move it between job sites. Even car companies are getting into construction robots. Chinese EV maker Xpeng developed Iron, a humanoid robot standing about 5 feet 8 inches with 60 joints that give it 200 degrees of freedom. Basically, it moves like a human. After 5 years of development, they get a design that allows it to perform tasks closely mimicking human movements. Iron has already demonstrated practical applications, such as assembling components for Xpeng's P7 Plus electric vehicle. Integrated with Xpeng's proprietary Turing AI chip, the robot leverages technology shared with the company's vehicles, enhancing its operational capabilities. Currently deployed within Xpeng's manufacturing facilities and retail environments, Iron aims to streamline operations and improve manufacturing efficiency, potentially transferring these capabilities to broader construction applications in the future. Semi-automated approaches to construction robotics can be just as effective as fully autonomous systems, and the SAM-100 from construction robotics works alongside human masons rather than replacing them. This semi-automated system uses a conveyor belt, robotic arm, and concrete pump to handle the heavy lifting while skilled workers guide the process. SAM-100 boosts productivity to 3,000 bricks per day, 6 times what a human mason typically manages. By taking over the physical strain, it reduces injuries and lets skilled workers focus on quality and craftsmanship rather than breaking their backs. This collaborative approach might be the most realistic path forward, combining the precision of robots with human judgment. Then there's Digit, Agility Robotics' take on humanoid robots for construction. At about 5 feet 9 inches, it's built to move through spaces designed for humans, handling tasks like moving boxes and managing inventory. Thanks to its advanced AI, Digit can adapt on the fly, making it especially useful in environments that require both mobility and dexterity. Big names like Spanx and Amazon are already putting Digit to work, using it to fill labor gaps and take on repetitive, physically demanding jobs. While it started in warehouse logistics, its ability to move materials efficiently makes it just as valuable on construction sites, where similar challenges exist. Agility Robotics sees a future where robots like Digit work alongside people, not just in warehouses but across industries, including construction. With its bipedal design, it can navigate human-centric spaces without the need for major modifications, bridging the gap between today's task-specific construction robots and the multi-purpose humanoid assistants of tomorrow. One thing is true, the future of construction is being built today, one robot at a time. Are you ready for innovation? Then subscribe to the channel and turn on the notification bell so you don't miss out on everything robotics has in store for us. See you soon.